In section 1.6, we are classifying polygons. So starting out, what is the definition of a polygon? It is a closed, plane figure formed by line segments, which are the sides, where each side intersects one other at each vertex. Alright, let's decipher all that. Closed plane figure. First of all, plane means it's on a flat surface. Closed meaning that eventually, once you create the sides, notice line segments form the sides, we will eventually have to work our way back to the beginning and close this figure, leaving open like this. This is not a polygon, but if I eventually go back to the beginning, now it's a closed plane, meaning flat, surface. It is formed by line segments as the sides. Each side intersects one other at each vertex. Notice at each vertex you have two lines intersecting. For instance, if you had another line segment intersecting here, this would no longer be a polygon. You can only have one line segment intersecting one other at every vertex. To name polygons, we list the vertices in order. So we'd have to put points for all of these. And listing these in order just means going around either clockwise or counterclockwise. You can name it by the type of polygon if you want, like this is a pentagon because it has 5 sides. So I can write pentagon if I want, I can just write polygon if I want, or I can just write in any order as long as I go around in one direction. Maybe I'll start with C, go to D, then I would have to do E, A, B, and complete it right before you get back to where you started. So name the vertices or name the polygon by listing the vertices in order. Clockwise or counterclockwise, there would be a lot of ways to name this polygon. One quick note then about what other qualities make something not a polygon. If it doesn't have line segments for sides, it's not a polygon. For instance, a circle is not a polygon because that's just one continuous rounded sort of line. I mean, I shouldn't even say line because it's not a straight line, right? So you have to have line segments for sides. Talking about convex versus concave polygons, convex polygons are kind of your more basic type of polygon. The definition that you're going to see is where if you extend a side into a line, that line will never be in the interior of the polygon. You see this rule is broken with these green lines that I did. I did dotted lines for every single side on this polygon, and none of these orange dotted lines entered the interior. And that's what makes this one convex, because none of those dotted lines ever broke the bounds of the plane figure. But here, when I extend this line, oh no, it's going into the interior, or if I extend this line, it's going into the interior. That makes this figure concave. Because of the fact that these two kind of broke the rule, by extending those sides, we entered the interior of the polygon. What I like to think, this is how I always remember the difference, is I think of this as caving in. And it caves in right here. This points inward towards the center of, or the interior of the polygon. So I always think of concave because it's caving in, it's pointing inward. I don't know if that helps you, but convex is your more typical polygon you'll see, where if you extend all the sides, you never enter the interior like we did here. So basic example, first of all, tell whether these figures are polygons, and then decide whether they're convex or concave. I guess the first question would be, do any of these break the rules about being a polygon? This is closed, line segments for sides. This is a polygon, this star shape. This here, closed, line segments, only one line segment meets every other at a vertex. This is also a polygon. This here, this curved, rounded sort of line or side in a sense, that is not a polygon. Because of that roundness, it's not line segments, it's not straight lines. This is not an actual polygon. Let's also decide whether these things are convex or concave. Again, I like to think of concave is that figure is caving in, it's pointing inwards in some spots. Remember that convex, if you extended the lines, you would never enter the interior. This one, this star shape, you should be thinking concave because of all the times that these sides point inward towards the center. Or if you think if I extended any of these sides, you would enter the interior. Any way you think of it, this is concave. It's caving in. It's not convex because those sides enter the interior. Here, well, if I extended all these sides, they would stay outside. Nothing's caving in. This is convex. And similar thing here, nothing is pointing inward. Nothing's caving in, extending, well, this line would be fine. So this would be convex, the more regular type of polygon. Alright, naming is important. We're talking about the names of polygons, and we name polygons by the number of sides. To actually even be a polygon, 2 sides is an angle, 3 sides is the first and lowest number of sides that we can have on a polygon. And you should know that any 3-sided polygon is called a triangle. A 4-sided polygon sometimes gets people because there are so many different types of 4-sided polygons. We can talk about squares and rectangles and trapezoids and rhombuses and kites. But do you know the general term for any 4-sided figure? And the prefix kind of helps you out. Any 4-sided polygon is a quadrilateral. And yeah, squares, rectangles, rhombuses, kites, that type of thing all fit under this category of quadrilateral. And parallelograms, trapezoids. But the general term is quadrilateral. It covers any 4-sided figure. 5-sided polygon we've seen a few times this year is a pentagon. Pent or penta means 5. A 6-sided polygon. This one is pretty common in real life too. A lot of gazebos are hexagons. 6-sided. 7-sided, not as common. And there's a lot of prefixes for 7, but it's actually heptagon. You notice now everything ends with this agon because they are polygons, or that ends with gon, I should say. Those are all polygons. 8-sided. You actually see 8-sided polygons almost every day in your life when you're driving, because our stop signs are 8-sided. And if you know the name of 8-sided polygons, they're octagons. Think octopus, 8 legs, octagon. 9-sided polygons. It almost sounds like 9, it's nonagon. And then 10-sided polygons. This one you might be familiar with. The prefix for 10 would be deca. So this is a decagon. 11-sided polygons, they've thrown out different names for them but never agreed on one, so we skip that. Now a 12-sided is actually a dodecagon. It's like adding do, I guess, meaning 2 to decagon. So dodecagon. Now after that, I mean, it's not like we can't talk about polygons with more than 12 sides, it's just that we don't have a special name for each of them. After that, we just say the number of sides is given by n. And n could be any number of sides. It could be 15 sides, 20 sides, 30 sides, you know, whatever it might be. But we call it an n-gon. And again, they're polygons, so it's an n-gon. So I don't know, if you had something that had, say, 20 sides, you would call it a 20-gon. Just a way to talk about the fact that it is a polygon. And then n would be the number of sides, or 20. And we're going to use all this later in the year. A few more terms that we need to know is equilateral polygons and equiangular polygons and regular polygons. Now, equilateral, you pretty much see the word equal in here. Equilateral. We'll come back to this one. We'll talk about this first. Equiangular. Well, this is pretty much the word equal. You pretty much see the word angle in here. So equal angles must mean that all of the angles are equal. But actually, we need a better word than equals. We're talking geometry here. The angles are not equal. The angles are congruent. That's our term for the same or equals in geometry. So an equiangular polygon, the angles are equal or congruent in this polygon. An equilateral polygon, well, if it's not equal angles, it must be equal. What's the other part of polygons? It's got to be the sides. And that lateral, you can think of the sides there. So, okay, I'll just write angles again. My bad. The sides are congruent. And when we're saying equiangular, all the angles need to be congruent. When we're saying equilateral, all the sides are congruent, not just a few of them. So equiangular, equal angles, equilateral, equal or congruent sides. So what do you think a regular polygon is then? A regular polygon has all angles congruent and all sides congruent, meaning that it's both equilateral and equiangular. Equilateral, of course, meaning all the sides are congruent, and equiangular, meaning all of the angles are congruent. So regular polygon has both. All sides and angles are congruent. Remember, symbol for congruent there, equal with the tilde. So help me out here, classify the polygon. Tell whether it's equilateral, equiangular, or regular. I look here and I see, okay, first of all, for classifying the polygon, I know this is 3 sides, so this is a triangle. My question is it equilateral? Equilateral meant all sides congruent. I see 2 sides marked congruent, not the third, so it's not equilateral. Is it equiangular? I see 2 angles marked congruent, but not the third, not equiangular, so it's definitely not regular, because that would mean both equilateral and equiangular. So just a triangle there. What about this guy? We have how many sides? We have 4 sides. Now remember, the generic term for a 4-sided polygon is a quadrilateral. This is actually a special type of quadrilateral. We'll discuss those in a later chapter. Is it equilateral? Remember, equilateral meant equal or congruent sides. Hey, look at that. 1 tick mark for every single side. It's definitely equilateral. Is it equiangular? This means all angles are congruent. Well, these angles are congruent because they both have 1 arc, and then these angles are congruent because they both have 2. But it's not equiangular unless they're all exactly the same. So I'm going to classify this one as equilateral because we saw those sides were congruent. And finally, this last one on this page here. Wow, how many sides do I have? 1, 2, 3, 4, 5, 6, 7-sided polygon. That one's called a heptagon. Not as common as many of the others. 7-sided is a heptagon. Is it equilateral? Are all the sides congruent? Yep, 1 tick mark for all. Is it equiangular? Are all the angles congruent? Yes, 1 arc in each. Hey, it's both equilateral and equiangular. It is regular. All angles and all sides are congruent. Oops. Finally, last example here, a rack for billiard balls, if you're playing pool, is shaped like an equilateral triangle. What does equilateral mean? Remember, this means all sides. Lateral meaning sides are congruent. So if this rack is equilateral, all the sides are congruent, which means I could put 1 tick mark in each of these sides. Find the length of a side. Well, this side is given by 4x plus 2 inches, and this is 6x minus 4 inches. If I know it's equilateral, then these 2 lengths, these expressions, must be the same, congruent, or equal. So I can set 4x plus 2 equal to 6x minus 4. Again, it's equilateral. The sides should be congruent. They should be the same length. These should be equal then. I'm going to subtract 4x from this side and be left with 2x minus 4 here. I subtracted the 4x. It's gone. We just have 2 there. Let's add 4 to both sides. I get 6 there. Divide by 2. And x equals 3. But you notice it said find the length of a side. Now that x is 3, I plug that back in. 4 times 3 is 12. And 12 plus 2, this should be 14 inches. And let's check here if I plug in 3 again for x. 6 times 3 is 18. 18 minus 4 is, 14 inches. Length of a side. Okay, so talking about polygons, naming, and some special terms and definitions today.